Welcome. This one's take a look at evaluating this integral in the context of complex analysis. So e to the z minus e to the negative z over z to the fourth. So first what I'm going to do is I want to be able to find the value of this integral, so I'm going to use Cauchy for that. However, I need to first make my integral look more like the formula. So remember that the formula looks like this. It's 2 pi I over n factorial times f to the n a. And then on the right side, you have to identify the value of a, you have to identify the value of n, and you have to identify f of z, which is kind of like the function in the numerator. So here in our function, for that reason, I'm not gonna just write z to the fourth. Instead, I will write z minus 0 raised to the 3 plus 1, because that 3 in blue is my n, and that's relevant in this position above my head. It's also relevant in that position there. Okay, and that 0 in red is my a, so that's relevant in this position. It's also relevant in this position here, you see? Alright, so first I just rewrite things so everything can be identified clearly. Now I'm going to integrate here over z equals 1. So basically I'm going to go kind of like this way, according to the direction of the arrows. And the 1 represents the radius of the circle here, basically. And then the z is like a number on the circle somewhere. And notice that this 0 right here, this red 0, where it says z minus 0, that's at the center. It's inside the circle, okay? So with that in place, let's actually do the integration. So first of all, a is equal to 0. F of z is e to the z minus e to the negative z, and n is equal to 3. Identify key pieces of information that can be plugged into the formula. Now, I need to, here, find the following. Since n is 3, that tells me that up here, it should be f triple prime. In other words, third derivative. We have to go up to the third derivative, okay? That's our objective. So for that reason, I'm going to proceed as follows. F prime of z will be equal to e to the z minus e to the negative z times negative 1, because the negative 1 is the derivative of negative z. Alright, so it's going to give me e to the z plus e to the negative z. That's only the first one, though. Continue. F double prime of z will be e to the z plus e to the negative z times negative 1. Again, I took the negative z, differentiate to get negative 1. It's just a chain rule being used here. And it's e to the z minus e to the negative z. That's the second derivative. One more time. F triple prime of z will be e to the z minus e to the negative z times, again, negative 1, the derivative of the negative z there. So that's going to give you e to the z plus e to the negative z. Now what I need to do, because my formula relies on here, it's a third derivative evaluated at a. So I got to plug a into the third derivative. So when I do this, it's going to be f triple prime at 0, okay? So it's going to be e to the 0 plus e to the negative 0, which is then be 1 plus 1, which is 2. So I've got 2 as the value of f triple prime at 0. Good. So what I can do now is proceed as follows. Find the value of this integral e to the z minus e to the negative z over z to the fourth over that circle. So integrated over the circle there. That's going to be 2 pi I over 3 factorial. The reason is that, remember, this here is n, so that's n factorial. In our case, n is 3, so that means it becomes 3 factorial in that position. F triple prime of 0. So I continue as follows now, okay? It's going to be 2 pi I over, well, 3 factorial is 3 times 2 times 1. And then f triple prime evaluated as 0 is just 2, so it's showing up here as this Bluetooth. Cancel off that 2 with that 2 in the bottom, just like the red strike lines indicate. And you end up pretty much with that 2 in blue times the pi I, so it becomes 2 pi I, and then in the bottom what's left over is 3, so you end up with 2 pi I over 3 as the value of the integral using this formula right here, Cauchy Integral Formula. Notice that we don't actually have to do any integration, correct? This is just a beautiful result right here. We can just use that formula instead. Thank you so much. Please leave a like and subscribe. I hope it's been useful. I'll see you in another video.